deflection, stiffness matrix method. And in that we have seen the concept of stiffness matrix. Okay, before we start the actual analyzing numerical, first we'll see that what are the different steps that we have to follow during this analysis, so that it will be easier for us to carrying out the just a minute. Okay, this is a stiffness matrix, unit number 5. There's very simple unit is there, so we have to just write down the first is the steps. So first step is you have to find out always is find out the degree of kinematic indeterminacy. Is the first is this step that you have to follow. Then assign coordinate to. Second is assign redundant to degree of kinematic indeterminacy. Third is find fixed end moment. Find ADL considering redundant structure. Find stiffness matrix. Which is denoted by S. Next is number 6th. Use. Which one is better visible? First one or right now what I'm using is. Hello. Right now what font I'm using, is it visible good or first one is good?
The previous one is good.
Okay. So here I think that it was been okay, nice. Then use a basic equation, that is use stiffness equation, which is yes in the D is equal to ADL plus S into D. This is a stiffness matrix arrangement that we have already seen in yesterday. This we have to use. Okay, after using this we'll get the next value, that is of 7th. We will get unknown displacement. Maybe once you get unknown displacement, then next part is, 8th number part is you have to use slope and deflection equation to find final moments. Okay, then find support reaction, and last one is plot SFD and BMD. So here I will going to continue solve the problem up to find out the degree of indeterminacy, that is displacement we're going to find out. Rest of the thing in slope deflection that you already learned, so you can complete that one. Okay, find out the moments by putting in the equation. I will also show you some completing one problem. In that I will show everything over there. Then later on we'll see the, we'll try to cover the maximum varieties of problem in this particular category. Okay, so now have you completed these steps?
Yes, sir.
Okay, nice. Now see here, we'll see first one simple problem, then after understanding this, we'll go for the different variety. Analyze the given beam as shown in figure. Analyze the given beam as shown in figure by stiffness method. Okay, the simple beam will be like this. This is A. Okay, B is this, C. Over that there is a UDL in this span, and one load of here is acting to 50 kilonewton. This is 50 kilonewton. This is 2.5 meter. This is 1.5 actually. This is 1.5. This is 2.5, and this UDL is a 25 kilonewton per meter, and this distance is 3 meter. This is a beam which we have to analyze by using stiffness matrix method. Then later on we'll write down here is a next is the solution. Draw the diagram again for here. Then first step is what you have to find out is the degree of kinematic indeterminacy. In this case, dk. How much it will be?
2.
How is it 2? Degree of kinematic indeterminacy? Only one answer is there, 2. What about other people? What is the different answer?
0.
0. Okay.
0, sir.
How is it is 0? How is it 0? See that we have to see the degree of kinematic indeterminacy. We have to see the supports. So A and C are fixed support. This way for that it is 0. We agreed that for degree for this it is 0 as well as for 0. But B is roller. It will have a theta B. Yes or no? Agreed?
Yes, sir.
So dki for this case will be 1, that is theta b. Theta b is not equal to 0. Okay, what is the second step? We have to assign the coordinate to them. So let us assign d1 is equal to theta b. This is coordinate. Assigning means that we have to just give notification to this d1. Okay, here is only one, so we will have d1 only. Okay, now look, back to the coming back to the diagram. Here we can develop the three different diagrams. Here is this. Okay, at B there are two members which are meeting, so we can have those two diagrams will be separated like this, and every join will be restrained. Okay, see that here it is mentioned that first is we will find out fixed end moment and then ADL. Okay, we'll go first for a fixed end moment, we'll find out, then we'll go for ADL. Third step is fixed end moments. Now looking towards the diagram, so can anybody will able to calculate this? Here MFAB is equal to minus MFB to A is equal to how much it is coming. W is the load, that is 25. L is a span, 3 square divided by 12.
18.75.
18.75. Good. 18.75 kilonewton meter. For span BC, we have to calculate MFB to C is equal to WAB square upon L square. And then MFC to B is equal to minus WA square B upon L square is there. Okay, for this we will write down this W is equal to 50 into 1 into 2.5
11.718.
Yes, good. Yeah, it is 2.5 plus 3, 4, 4 square is there. 11 point.
718.
WEB square upon L square 50 into 1.5. This is not 1, here 1.5.
29.
29.30. That's not something. 29.30 kilonewton meter. Here W square by this, so minus 50 into 1.5 square into 2.5 divided by 4 square is there. This will be equal to
17.5758.
17.58. This is minus 17.58 kilonewton meter. Okay, this is there. So all fixed end moments we have calculated. Okay, so next we have to find out the ADL one. Okay, next is the we have to find out the ADL one. For that also you can directly calculate, but I will explain on the diagram also what is there in the, you can understand. You have to draw the separate diagram like this, and again for this we have to carry out a fixity like this. For this joint is also fixed, and for that also we have to consider that a restraint structure is this. So we have fixed up this structure. This is A, this is B, again this is B, and this is C. So we have calculated fixed end moments. So this moment is MF A to B. Here this moment is MF B to A. For another span, this is MF B to C is there, and for this it is MF CB is there. Okay, this is something which is ADL1 from the diagram. So difference of these two moment MFBA plus MFBC is ADL1, because this is a moment, because of that there is possible of having rotation. If MBA is equal to also 10 and MB to C is also equal to 10, so there is no other unbalanced moment which is going to rotate that joint. So there is no rotation of that joint. If there is no rotation, there is no displacement, there is no increase in the moments. But now in the looking to this diagram, this is ADL1, you can understand this. Then you will write down MF ADL1. Here at B we can write down is also. For I am understanding this is writing, otherwise this is not necessary. MF B to A plus MF B to C is equal to this ADL1. Okay. Now equal to means that here one moment we have calculated MF B to A is minus 18.75 plus this is 29.30. This is equal to how much it is equal to now?
10.55.
10.55. Good. This is 10.55 kilonewton meter. This is ADL1. Okay. Next step is we have to develop a stiffness matrix.
सर ADL1 मीन्स त्या दोघांचा डिफरन्स काढायचा का फक्त?
हा, त्या दोघांचा डिफरन्स काढायचा, कारण हे दोघांचा डिफरन्स म्हणजेच ती अनबॅलन्स मुवमेंट ज्याच्यामुळे रोटेशन होणार आहे. अदरवाईज रोटेशन झालंच नसतं. एक क्लॉकवाईज एक अँटी क्लॉकवाईज आहे, बरोबर आहे. दोघं सेम असेल तर रोटेशन होणारच नाही. Okay.
Yes.
Now here for stiffness matrix we'll draw the diagram. Okay. Remember, if you remember yesterday's diagram, this we have to plot over here only for this B joint. Okay. But remember that here in a B there are two members. At B there are two members. One is A, B to A is there. Another member is B to C is there. Okay. If you remember yesterday's diagram for member AB, okay, तर तुमचं हे होतं. First case always we have to draw. Now here B theta B is not equal to 0. So we have to apply that theta B is not equal to 0 means we have to consider theta B is equal to 1 for AB span also and for B to BC span also. Okay. Now we have seen that this is AB was there. जेव्हा थीटा बी ला 1 पाहिजे होतं तेव्हा डायग्राम अशी होती फॉर दिस ए टू बी केसमध्ये. आता दुसऱ्या केसमध्ये काय होईल, ही डायग्राम बी टू सी होईल अशी. बी टू सी इज देअर. सो अगेन थीटा बी इज 1 म्हणजे एच्या ठिकाणी कोण आला आता, बी. सो डायग्राम नेचर विल बी सेम बिकॉज हिअर अँटी क्लॉकवाइज रोटेशन्स आर पॉझिटिव्ह. सो विल गोइंग टू दिस इज थीटा बी हिअर. So theta B of this B to C plus theta B of the A to B is your S11. That is your stiffness matrix for this. Okay, we'll explain in the diagram also. Then we will have the diagram for the member B to A is like this, as B is farther end and its rotation in anti-clockwise way is this. Okay, this is the theta B. Then similarly for B to C, this rotation will be like this. Okay, one diagram will be like this. So this again will have a tangent of this and there is theta B is equal to 1. And addition of all these to his total is your S11. The total stiffness of this for okay, for this also and for this also is your S11. This is your stiffness. As only one unknown is there, so stiffness matrix will be having size only 1. S11 is there. 2 is there, then 2 by 2 is there. We'll see the first problem of one unknown, then we'll see the second problem of two unknowns are there. Now stiffness matrix will be here S11 is equal to, how we have to write down this, 4EI by L. Unit positive rotation means 4EI by L. Okay, theta A is there. Okay, let us say instead of theta A we'll write down for B to A and then plus 4EI by L is for B to C is there, S11. Okay, addition of these two, you just put the values in this. So here 4EI divided by 3 for AB plus 4EI divided by another span is 2.5 plus this 4 is there. So this is equal to 2.33. Yes or no? 2.33 EI theta B. EI theta B is there. Now later on we have a basically stiffness equation is that is we can say D is equal to ADL plus S and into D. So this D is we have to always, otherwise you can have one more notation is AD you can calculate here like this. So you can there D is twice, so you will have this notation like AD also you can add over this instead of this AD. So always these are 0. Okay, when it is 0, suppose until and unless there is mention like that there is a displacement of joint. So this D will come into the picture only after initial displacements are present over there. It means that whatever the displacement is going on, that is because of force that we are calculating. Okay, we are calculating the displacement because of force, rotation because of force, or rotation because of moment. But before the rotation, is there any positive rotation of that joint is there? Then and then values of this will come. Suppose initially let us say that at B there was initial rotation was 0.04 radian is there, and now this is going to change or this is going to have addition because of this displacement, then we'll have the value of here 0.04. if it is not mentioned, so always take this as a 0 in any of the problem. Only thing is that when we find out theta, at that time we have to consider moment. Or when if we are finding out the delta, we have to consider force. Okay, in the same problem, if in the same problem at B is an intermediate joint is there, we are calculating this rotation because of these forces UDL as well as point load is there. But at the same time, if there is one moment which is acting over here, couple is acting over here of 10 kilonewton, then this will have a value over here 10 kilonewton. Otherwise, it will not have value in the structure. The couple which is acting at joint, otherwise this will not have any value in this structure. Because of this 10 kilonewton, this is additional moment or additional rotation will be there, and this 10 kilonewton is not considered anywhere in the fixed end moments, free span moment is not we have considered. Have you considered that? No. In the even matrix format is not considered. So if there is couple acting while we calculating a rotation, while we determining a rotation, if any couple acts at that joint, that we have to consider in this region on the left hand side of the matrix. So in this structure it is not mentioned, so we're going to consider this as 0. So this will be 0. ADL you have calculated, that is initially here ADL you have calculated, it is 10.55. Stiffness matrix we also calculated, that is 2.33 EI. This is EI only, not a theta B. Here D1 you can write down here theta B, or you can write down like D1 is also. Okay. From this you can find out rest of the things. Can you find out the value of theta B here? D1 or theta B is equal to theta B is equal to here minus 10.55. This is plus minus 10.55 divided by 2.33. So theta B is equal to minus
4.5278.
4.2578, right?
5278. Yes.
Okay, 5278. 5 to 8 you can write down directly, 5 to 8 also. 1 upon EI is there. Okay, this is the end of slope deflection method. Once we get theta B, next is the use slope and deflection equation to find moments. So later on, this is MAB is equal to, you can have MAB, MFAB. You already calculated. This is 18 point. MFAB you calculated 18.75 plus 2EI by L theta B. So you can write down this 2EI. L is the span, that is 3 meter, into theta B you calculated minus 4.52 upon EI. You just put this value, you will get MAB. Then MB to A is there, minus 18.75 into 4EI divided by L is 4 into minus 4.52 upon EI. This is equation I am writing. This is the slope deflection equation. You already aware about these equations. Then later on, next equation is MB to C is there. Is plus moment, that is 28.29.30 plus 4EI by 4 into minus 4.52 upon EI is equal to this. Oh, no, this is EL. Here EL is equal to 3. Here put, here is L is equal to 3. 4 EI by 3 is there. It's 4. Then EI is there. Then MCB is equal to minus 17.58 plus 2 EI divided by 4 into minus 4.52 upon EI. Tell me the answers. Can anybody has calculated this?
MFAB 15.90 kilonewton meter.
15.90 kilonewton meter. Okay.
MFB8 minus 22.53 kilonewton.
Kilonewton meter. Okay. MB to C.
$24.78.
24.78. How this is difference? BA and BC should be same.
25.02 येते.
वरचं का?
हो सर. नाही 25 पॉइंट खालचं 25.2 येते.
अरे this should be same. This should be same. Something difference. 25.02.
MBA is minus 24.77 and MBC is also 24.77.
This should be same.
Yes, sir.
24.78.
24.78.
Yes, sir.
or okay. This is this. 24 point. Otherwise, the joint, if this joint is not balanced, then what is the use of solving this problem? MCB is equal to later on, last one. This will have a minus, actually both are minus. Minus 2 into 5. This 4.52 divided by 2, it will be, comes out to be 2.26
Minus
plus
19.84.
minus 19.84 kilonewton meter. Okay, likewise you can calculate moment. Once you get moment, try to find out support reaction, plot SFD and BMD. This is your part. Now after completing every problem, leave some space, and whenever you get a time, you complete that SFD BMD. Okay, I will going to take next problem which has 2 unknowns. Okay, that is my interest, keen interest to take this problem, because also we'll try to see the extend movement over there. Okay. Okay, this is enough for. So analyze the beam. You write down the statement. Analyze the beam shown in a figure. By slope deflection method. Let us say again, we'll take some simple problem. We'll have suppose here is some variation in moment of inertia. This is I and this is a 2I is there. So how to deal with this, that is also will be seen in this scenario. First find out the degree of kinematic indeterminacy in this problem.
2, sir.
Yeah, dki is 2, very correct. And here this in dki, if you observe this, only 2 in this theta b and theta c are not equal to 0. 0. Second, let d1 is equal to theta c and d2 is equal to theta b is there. Maybe let us assign this. Third step is find out the fixed end moments. So you all of you please calculate the fixed end moment for this. Calculated anyone? MF
41.67 kilonewton meter.
MF AB is equal to minus MFBA. Please all of you calculate the correct bending moments. Otherwise you will get some different answer, and that is also creating trouble in last. Okay. So all of you please 2 or 3 persons please put your answer in chat box so that it will be verified also. Or you can speak at least.
41.67.
41.67 kilonewton meter. Nice. Then later on we have the MF B to C is equal to minus MF CB. This is also having a same formula W
90.
90 90.
90 kilonewton meter.
Yeah,
Yes,
90
sir.
kilonewton meter. Okay, we got this. So let us calculate the ADL1 and ADL2. Here in ADL1, if you look to the diagram, if you look to the diagram, ADL1 is the addition of MFB to A plus MFB to C, and this is MFCB is there. Okay. ADL1 and ADL2 is there. So we calculate ADL1 is at B, so MF B to A plus MF B to C is there, and ADL2 is equal to MF C to B. You can directly write down this now. Here it is minus 41.67 plus 90. This is equal to, and this is equal to minus 90 kilonewton meter.
48.33.
8.33.
48.33 kilonewton meter. Next step is to find out the stiffness matrix. I will draw the diagram. So for understanding this is in first diagram, suppose here there will be diagram for S11. Actually, one we have assigned for theta c. So this will be the diagram for this. Here c is there, theta c is equal to 1. This will be your S11, and the effect of this in the same direction is your S21 when theta c is equal to 1. This diagram is for this theta c is equal to 1. Later on this second diagram, this is for B this region. This is for the another. This is there. This is theta B and this is theta P. Okay. The addition of this addition of these two is your S22 and its effect on the farther end is your S12. This is for the distance. Okay, understood this diagram? Yes or no?
सर एक्सप्लेन करा ना एकदा फक्त.
Okay. Do you remember yesterday's diagram? For A to B is there for first case when theta A is equal to 1. At that time your diagram was like this. Anti-clockwise rotation are measured in this way, anti-clockwise. So we have to measure in an anti-clockwise way. So theta A is equal to 1. This was the first case for theta A is to be 1. When theta B was 1, at that time our diagram in the, for A to B is this. So again we have to measure in a anti-clockwise sense. So we have to measure it in anti-clockwise sense. We have to draw a deflection like this. Deflection like this. This is theta B is equal to 1. And if you draw a tangent over this, it will be in anti-clockwise. It will be like this. So causing these moments here like this and here in the these things are there. And in every beam, okay. Now what will happen? Initially, in a continuous beam, what will happen? This diagram will be overlapped for this. See that this is overlapped. Okay, what I am doing is now you can observe this. Just I am overlapping these two diagrams over this. Understood this? Oh.
Yes, sir.
For B, if this joint is continuous, see that at B, one end is towards this side, another end is towards, one end is towards the A side. If for A diagram will be A to B to A is this, and see that for A to B, A end is this and C is towards this side. But for B to B, I have one, that will be diagram will be for AB span will be like this, for BC span it will be like this. And always remember that this is to be the always case, always, even though this column now, if it beam become column now, we have to rotate in vertical 90 degree. Diagram will be same. Here one important is that always we have to measure the rotation in anti-clockwise direction. Suppose we are want to now here we want to theta is equal to 1. So rotation to be measured in anti-clockwise. So we have to have a draw a deflection in this way. Only this. Okay. So likewise here we can apply here S22 and this. So here in the first case, S11 is equal to 4EI by L, that is for B to C. Now in here I is equal to 2I. So you will write down 4E into 2I divided E by L. L is equal to 6. This is equal to how much it is coming?
1.33.
1.33 EI is there. Okay, 1.33 EI is there. Then next 6 sorry, S11 is there. S12 is equal to S12 is equal to 2 EI by L, that is for B to C. So this is 2 EI divided by L is 6.
तर B to C 2I आहे ना.
Yeah, 2I is this. I we have to put here actually 2I. 2E into 2I divided by 6.
0.6.
Okay, good. 0.667 EI. 1 2 is there. So then S22 will calculate first, that is 4 EI by L, that is for B to A, plus 4 EI by L, that is for B to C. Now here 4 EI divided by 5 plus 4 EI E into 2I divided by 6 is equal to this, and S21 is equal to 2 EI by L. How much it is coming?
Is 2 is 2.13.
2.13. Okay, 2.13 EI. And for 21, S21 is this. See that S21 means after applying S22, yes, here diagram it is. And both are actually same. This will write down S21 and this is S12. So this will be same actually. S12 and S21 will be, most of the time these will be similar to each other. This is 0.667. Yes, is it right?
Yes, sir.
0.667 EI is there. And now just have a stiffness matrix arrangement, that is AD is equal to ADL plus S into D. So here initially all the there is no moment, okay, no moment. No moment means no couple acting at joint, acting at joint. So AD is equal to 0. So even after writing this, I don't know how many of you are able to do this or not. So 2 by 2, so 2 is there. ADL we have calculated initially in the above steps, 48.33 and minus 90. Plus stiffness matrix, that is also we have calculated here, 1.33 I. You can have this 1.33, 0.667. This is 0.667 and 2.13, that is EI is there. Okay, this is there. So multiplied by D, that is D1 and D2. So D1 is our theta C and D2 is our theta B, or you can directly write down D1 and D2 also. Okay, so this is the equation. Now you solve this equation, you will get theta B is equal to and theta C is equal to. This is what I want. How much it is answer?
Theta B minus 68.24.
Other people, please verify this. Minus 68 point. Yes, Vaibhav?
94.
24.
90, okay, upon EI and theta C
63.62.
63.62 upon EI. So later on, use the slope deflection equation. And plot SFD BMD. This is the rest of the work that you can complete later on. Okay. Understood this problem? Is there any difficulty for currently in this problem? Is anything that you haven't understood? Any one of you not understood anything? So you can ask this. Instead of here, I have written down here in the diagram where stiffness diagrams are there. If you want, you can write down this also like this. Suppose this is 4EI by L. For this span as well as for this, it is 4EI by L. Then this will be for again, you can write down directly 2EI by L. This is also possible. This moment is again 4EI by L and this is 2EI by L. For avoiding confusing, or you can calculate from this diagram. These diagrams are not part of your solution. Only thing is that we have to understand that it at an intermediate joint, we have to consider the stiffness of the joint, the B to A as well as for B to C. That we have to consider. That's why we have taken this. If you don't have any doubt, yes, there is one problem for you, that is your tutorial work. So take down this, analyze the structure by using stiffness method. (15 kilonewton per meter). This is 12 kilonewton per meter. This is A, B, C and D is there. 1.5 meter, 6 meter, 75 kilonewton. Okay, this is a problem. I have modified this because this one end is having overhanging beam. Okay, and if you I have understood this, this is also similar way you have to carry out this. Okay, I will also explain that how we have to approach actually if we find out the degree of kinematic indeterminacy. What we have done in a slope deflection method for overhanging beam, same approach we have to use in this case also. Here DKI, we have to find out the degree of kinematic indeterminacy. How much is the degree of kinematic indeterminacy for this case? Can anybody?
2, sir.
Okay, 2. Okay, good. Which are those not unknown?
Theta B and theta C.
Okay, theta B and theta C. But if we observe that this is a D is a free end. D is a free end. At that time, theta D and also delta is also present. So in this case, first we have to modify the structure. And it will be modified like this. Okay, I will show it to you and you can, so this in the, after modifying you can use this structure for the analysis. Then the degree of kinematic indeterminacy will be 2. Here it is, suppose this joint. This is 75 kilonewton. 2 meter is there, 3 meter is there, 15 kilonewton meter, and this distance is 6 meter. This is A, B, C is there, and whatever this overhanging portion is there, na, this overhanging portion. So this will be considered in terms of moment over here, and that will be like 12 into 1.5 square by 2. 12 into 1.5 square by 2. How much it is coming? If you transfer this overhanging as a moment, yes, 13.5,
Yes, sir.
13.50 kilonewton meter. First, you modify the structure, overhanging structure like this, and then you can start the actual solution. And then you can say that degree of kinematic indeterminacy 2. Rest of the procedure will be same as the previous problem. But only thing is that there will be change in where we have considered AD. AD we have considered, okay, at whenever suppose C, you assume that C is equal to theta d1, C is equal to d1 is there, so then AD1 is there, also AD2 is also there. AD2 is equal to 0, that is for B, but here AD1, that is at C, there is overhanging moment sorry, overhanging moment is present, overhanging couple is also present over there. So here AD1 is equal to minus 13.50 in the equation where where stiffness equations are there, that at that location you have to add only this minus 13.50. Initially what we have done in the equation where we have AD is equal to ADL plus S into D is there, at that time for both we have considered as a 0, but here according to your assumption whether it is, if your D1 is equal to theta C, then your AD1 not will be 0, it is minus 13.50. This we have to accommodate in this way. In this way, when these values are coming, these values are coming when there are moments or couples are acting at that joint, then and then these values will come over there, otherwise it will be always 0. Understood this? Yes, no?
Yes, sir.
Yes, sir.
If you want, I can share